Hello everyone, in this video I'm here for the solutions of IB HR Mathematics Paper 1 questions in this year with time zone 1, which is America's countries. And last time I made a video about the solutions of uh, November papers of HR Mathematics. So I hope this video will help, especially for the students who will take the exam in this year May, I mean next year May. And yeah, we can start for the questions of paper 1, time zone 1. And I will also share the all of the time zone questions of paper 1, paper 2, paper 3. So follow me and subscribe my YouTube channel. Thank you very much for watching. Yeah, let's start. Yeah, the first question is consider the function f of x equals 4 times x cubed over 3 minus 16 times x, where x is a real number. The graph of y f of x has a local minimum point at p, q, where p greater than 0. Find the value of p and the value of q. So it's asking for the minimum point. Yeah. Yeah, to find the minimum point of a function, we need a derivative of the function. In this case, we're going to find the derivative of this function, right? So what's derivative? Uh, I'm taking to the power to the down. 4 times 3 times x squared divided by 3 minus 16, because I know that the derivative of minus 16 times x equals minus 16. And then it's going to be equal to the 0. Cancel to the 3's. 4 times x squared minus 16 equals 0. So 4 times x squared equals 16. X squared equals 4. From here, we can say that we have two solutions. One of them is 2, and the second one is minus 2. We are looking for the local minimum, and it say that the point is the abscess of this point is greater than 0. So it needs to be 2, right? But from here, you can also, from the sign table of the derivative function, you can prove that 2 is a local minimum, and you will start by positive sign, and then minus and negative sign, and again positive sign. So from here, you can see that 2 is a minimum point because at the left side of 2 is decreasing. I mean, the function is decreasing. When the derivative is negative, means the function is decreasing. So the right side of the 2, the function is increasing. So, we can say that at 2, it has a minimum point. We found p, which is 2, and to find the value of q, we're going to substitute 2 into the function f. Let's find that. 4 times 2 to the power of 3 divided by 3 minus 16 times 2. And from here, we can say that 32 over 3 minus 32, which is minus 64 over 3, right? This is the value of q. Yeah. Yeah. The second question, Bob invests 1,000 dinar in an account which pays a nominal annual interest rate of 4% compounded quarterly. The amount of money in the account after one complete year can be written as 1,000 times 1 plus k to the power of 4, where k is a rational number. Write down the value of k. So you can also check the formula from the formula booklet. You will see that there is a formula in here. So this is the present value of and the number of times, n is the number of times of the year, and k is the number of compounded periods per years, which is at the denominator, and r is the percentage, is the nominal annual rate of interest. So I will write it here, and it's gonna be 1,000 times 1 plus 4 over 100, which is 4 percentage, and it's going to be divided by 4 because we know that this is compounded quarterly. And at the same time, you will also write to the power, which is k times n. It means k is oh, which is k is the number of compounded periods per years, 4 times 1 year. And from here you can find, actually we found it, and the k is gonna be 4 divided by 100 times 4, which is 0.01. Yeah. And now we're gonna expand 1 plus x to the power of 4. For the coefficients, you will write the combination. You can start by 4, choose 0 times it's gonna be 1 over 4. I mean 1 to the power of 4. You don't need to write this, I mean, because 1 is it's not gonna affect the multiplication. And then x to the power of 0 plus 4 choose 1 times x plus 4 choose 2 times x squared plus 4 choose 3 times x cubed plus 4 choose 4 x to the power of 4. And simplify this. The first one is gonna be 1 and 4 choose 1 is 4 times x plus 4 choose 2 means 4 times 3 over 2 factorial times x squared plus 4 choose 3 is equal to the 4 choose 1, the attribute of combination, so you can write 4 times x cubed plus, and 4 choose 4 is also same with 4 choose 0, so it's gonna be 1 again and x to the power of 4. And simplify again, 1 plus 4 times 6 plus 6 times 6 squared plus 4 times 6 cubed plus x to the power of 4. Yeah, this is the question B. At the question C, it's asked for hints or otherwise find the amount of money in the account after one complete year. So we know that our money gonna be 1 plus, you can write here 0.01 to the power of 4. And from here you can see that you will just multiply 1000 by when you substitute 0.01 into the x, you will find this expression. So 1 plus 4 times 0.01 plus 6 times 0.01 square plus 4 times, the remaining you don't need to write because it's already close to the 0. And then you can write from here 1000 in parentheses 1 plus 0.04 plus it's gonna be 6 times 10 to the power of minus 4. Yeah. And when you multiply it by 1000, it's gonna be 1000 plus 40 plus 0.6, and then which is 1040.6. It is approximately 1041 dinar. Yeah. Question 3. Find the area completely enclosed by the curves y equals e to the power of x and y equals minus e to the power of x, and the lines x equals minus 1 and x equal 1. So I will draw these functions, and I know that e to the power of x is going to be exponential function which passes out the 1 on the y-axis, and actually minus e to the power of x is going to be a reflection of this the first function about x-axis, right? So it's going to be in this graph, and then we know that the line x equals minus 1 and the other line x equals 1, and we are looking for the area in here. So I will use the integral, and the limit is from minus 1 to 1. At the up there is a function e to the power of x, and we're going to subtract the other function which is minus e to the power of x. So that is 2 times e to the power of x, and you can take out this 2, and I know that the integral of e to the power of x is going to be the same. So in this case, I will just substitute the limits of this integral into the e to the power of x. It's going to be 2 times e minus e to the power of minus 1, and you can write 2 times e minus 1 over e. Yeah. Question 4. Consider events a and b such that probability of complement of a equals probability of a union b, which is a or b, equals 3 over 4. and probability of B given A equals to 2 over 3. Find probability of A and B. So I know that probability of complement of A, it is 3 over 4. And let's remember this, the formula, which is probability of A plus probability of complement of A will be 1, right? From here, you can write that probability of A is 1 minus 3 over 4. Yeah, I will use it, this number. And then what is the conditional probability, which is probability of B given A? And from formula booklet, you can check this formula is going to be probability of A and B over probability of A. So I know that this is 2 over 3. And I will use the probability of A, which is 1 over 4. And from here, I will find probability of A and B. Yeah. Just make a cross product. Probability of A and B is going to be 2 over 3 times 1 over 4. From here, you can write 1 over 6. Yeah. At the second question, show that events A and B are independent. And to do that, I will check whether if A and B, probability of A and B equals probability of A times probability of B. So if this equation is occurring, it means the probability of A and B, I mean the events A and B are independent. So I know that probability of A and B, it is 1 over 6. I know the probability of A, but I need the probability of B, and we can use the union probability and the formula, and you can also check from the formula booklet. It is probability of A plus probability of B minus probability of A and B. So I know that probability of A is 1 over 4, and probability of B I'm looking for, and probability of A and B is 1 over 6. So the union probability is given 3 over 4, and probability of B is going to be 3 over 4 minus 1 over 4 plus 1 over 6. From here, it's going to be 2 over 4 plus 1 over 6, and just it's going to be 8 over 12, which is 2 over 3. And then let's check if there is equation. So probability of A is 1 over 4 times probability of B, which is 2 over 3. Yeah, 1 over 6 equals 1 over 6. You can say that A and B are independent. Question 5. Consider sequence of 10 rectangular picture frames F1, F2, screwing F9 and F10. Picture frame F1 has width 4 cm and height 5 cm. The width and height of picture frame Fn are each increased by 50% to generate the width and height of the next picture frame Fn plus 1 for n is a positive integer and between 1 and 9. Show that the area of picture frame Fn is 20 times 9 over 4 to the power of n minus 1. So I know that the first one, the area of the first one is going to be 4 times 5, 20. But the second one, and the width and height of picture frame is increased by 50%. So it means 4, we need to multiply it by 1 plus 1 over 2, which is 50%. And I know that the height of this frame also gonna be 5 times 1 plus 1 over 2, right? So this means 20 times 3 over 2 squared. And then uh, for the frame third, again, so this was the width and this was the height of the second frame. In this case, the third frame, the width will be 3 over 2 times 3 over 2, and the height will be 3 over 2 times 3 over 2, because I know that the previous height increased by again 3 over 2. So from here you can say that the area of this frame will be 20 times 3 over 2 to the power of 4. And as you can see, and our ratio will be 9 over 4 because it's going to the power of 9 over 4, like 1, 2, 3. And in this case, you can write Fn equals actually F1 times, since it is geometric sequence, you can say 9 over 4 to the power of n minus 1. And I know that the area of F1 is 20, so which is 20 times 9 over 4 to the power of n minus 1, right? Yeah. Hence, find the mean area of the 10 picture frames, giving your answer in the form like this. So, the mean area, right? So, I need to add all of this area from F1 to the Fn. We have 10 frame, so you can write 20 plus 20 times 9 over 4 plus is going until 20 times 9 over 4 to the power of 9, right? From here, you will use from the formal booklet. In here, you can see the first term times 20 times 1 minus 9 over 4. Yeah. To the power of 10 over 1 minus 9 over 4. So from here you can write 20 times 1 minus 9 over 4 to the power of 10 divided by minus 5 over 4. And you can write, and if you take this minus into the parentheses, you will see that 9 over 4 to the power of 10 minus 1. And 16 times 9 over 4 to the power of 10 minus 1. And I am looking for the mean of these 10 frames. In this case, mean equals 16 over 10 times 9 over 4 to the power of 10 minus 1. So in this case, the number P is 16 over 10 or 8 over 5. And the number A is 10, right? This one, yeah. At the question B, find the median area of the 10 picture frames, giving your answer in the form like this. So, what's the median of these frames? Since that is 10 terms, you can say that the median gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the median gonna be mean of these two terms. So I can write that f5 plus f6 over 2. So what is f5? It is 20 times, you can say 9 over 4 to the power of 4 plus 20 times 9 over 4 to the power of 5, right? So I will cancel 20 by 2. It will 10 in parentheses, or you can say 10 times 9 over 4 to the power of 4 parentheses, 1 plus 9 over 4, right? Yeah. And from here you can say that this one is 13 over 4. 13 over 4 times 10 times 9 over 4 to the power of 4. Let's cancel it with 2. And then it's going to be 65 over 2 times 9 over 4 to the power of 4, right? In this case, we can say that Q is 65 over 2. Question 6. The line L1 has vector equation R equals 4I minus K plus lambda times A times G plus K, where A and lambda is a real number, and the line L2 has vector equation like this. The lines L1 and L2 are perpendicular and intersect at a unique point. Find the value of A and the value of B. So I would like to write uh, L1 in the vector equation. Yeah, I would like to write L1 in the form of like, and I know that this is, you can say 4, 0, minus 1, because I need 4 times I plus 0 G minus 1 K, right? Plus lambda times, you can say that the coefficient of I is 0 and A, and the coefficient of K is 1. So for L2, you can say the same, and the coefficient of I is 1, G is 0, and K is minus B, plus nu times 1, 2, 3. And I know these are the direction vectors of both line, and since these are the perpendicular each other, I can say that the scalar product of these two vectors, I mean direction vectors, is gonna be 0. So what's the scalar product? I'm gonna multiply these dimensions, 0 plus 2 times A plus 3 equals 0. In this case, A equals minus 3 over 2. So again, uh, and these lines intersect at a unique point. So I can say, for example, the x dimensions of L1 from here, you will see that actually it's gonna be 4 plus 0, and the x dimensions of L2, the line 2, it's gonna be 1 plus nu. In same manner, y dimension of L1 is gonna be a times lambda, and for L2, line 2 is gonna be 2 times nu. For that, you can say, or yeah, you can say minus 1 plus lambda, and for line 2, the dimension of z is gonna be minus b plus 3 times nu. So let's equal these dimensions first. 4 equals 1 plus nu. So from here you can say that nu is 3. And then for the y you can say that 8 times lambda equals 2 times nu. And this is 8 times lambda equals 2 times 3, and yeah, and then for that you can say that minus 1 plus lambda equals minus b plus 3 times nu, right? So I know that nu is 3. And I know that from here you can say you can find the lambda actually. I know that this a is minus 3 over 2 times lambda equals, yeah. So cancel these, lambda equals minus 4, and I will write here minus 4 minus b plus 3 times 3 because nu is 3. B equals 9 plus 5, which is 14. So yeah, I found all of them. Question 7. Consider the complex number z equals 3 to the power of I minus 1. Write the integer 3 in the form e to the power of a, where a is a real number. So 3 is gonna be equal e to the power of a, and from the attribute of the logarithm, which is the inverse of exponential function. So you can say that if that is log base a of b equals c, you can also write this a to the power of c equals b, right? So I will use this attribute and I will change the function into the logarithm. So from here you can say that log base e of 3 equals a. And we found a, which is ln 3. So 3 gonna be e to the power of ln 3. Yeah. And at the question B, hence giving your answers in the form p times cosine ln q, where q is a positive rational number, find the real part of z. And yeah, I know that z equals 3 to the power of I minus 1, but I will use e to the power of ln 3 instead of 3 to the power of I minus 1. So you can also write this e to the power of ln 3 times I times e to the power of minus ln 3, right? Yeah. And we need to remember now the polar form, I mean Euler form of a complex number. What is Euler form? If there is e to the power of I times theta, it means cis theta. What is cis? It is cosine theta plus I times sine theta, right? So let's use this. And I will write cosine, because I know that the angle is now ln 3, cosine ln 3 plus I times sine ln 3, right? Times e to the power of minus ln 3. So actually this one you can write if 3 equals e to the power of ln 3, and this means 3 to the power of minus 1, which is 1 over 3. In this case, I will write the real part of that. I will just multiply this because I know that this is the imaginary part, right? So the real part of that, e to the power of minus ln 3 times cosine ln 3, or 1 over 3 times cosine ln 3. Yeah, this was the first one of B. At the second one, it's ask for the reciprocal of z. So I will find, I will also use the Euler form of a function. So if z is, and I know that z is, I'm gonna write in the polar form. It is cis, let's say ln 3 times 1 over 3, right? And the reciprocal of this complex number is gonna be, this is the attribute of a actually polar form. If you will find the reciprocal of z, you will just change first the angle sign. It's gonna be negative ln 3, and also this is the magnitude of a complex number. You can think like a vector, this complex number. So the reciprocal of 1 over 3 is gonna be 3. In this case, the real, let's write it in a polar form again. It's gonna be cosine minus ln 3 plus I times sine minus ln 3, right? Times 3. So the real part of 1 over z is gonna be 3 times cosine minus ln 3, right? Yeah, 3 times cosine minus ln 3. Or you can, you can just write even 3 times cosine ln 3, because I know that this sign is not important if it is in cosine. Yeah. Question 8. Sima claims that n greater than log base 2 of n for n is a positive integer. Show that 1 plus log base 2 of n is equal to or greater than log base 2 of n plus 1. We're going to show that 1 plus log base 2 of n is greater than or equal to log base 2 of n plus 1. So I know that n is a positive integer number. which is n greater or equal to 1. In this case, I would like to add n to the both sides, and I will see that 2 times n is greater or equal to n plus 1. So why I do this? Because if I take or use the logarithm base 2 of both sides, it's gonna be log base 2 of 2 times n greater or equal to log base 2 of n plus 1. So I know that from the attribute of logarithm, I can write this log base 2 of 2 plus log base 2 of n is greater than or equal to log base 2 of n plus 1, and log base 2 of 2 is 1. Yeah, so we show it, yeah. And the second question, use mathematical induction and the result from part A to prove that Seema's claim is valid. Seema's claim is if n is greater than log base 2 of n, right? So what we found at the first question, this inequality, and I will use mathematical induction to prove that. Yeah. So how are we gonna use the mathematical induction? You will just start by check if for n equal 1, uh, this inequality is true. Yeah, this is true because I know that this means 1 is greater than 0 because log base 2 of 1 is 0. Yeah, so you can say that for n equal 1, this inequality is true. At the second step, this is the first step. At the second step, you will assume that for n equal k, this claim is true, and we're gonna show that if for n equal k plus 1 is this inequality is true. Yeah, our goal is to show k plus 1 if that is k plus 1 greater than log base 2 of k plus 1. I will write this k here. And what we know from the question A, we can write, for example, and I know that 1 plus log base 2 of k is greater than or equal to log base 2 of k. It was plus 1, right? Yeah, I will use parentheses here. Yeah. And what else? And I know this inequality is true. In this case, for example, let's use that since k is greater than log base 2 of k, and I can add, for example, 1 to the both sides, and it's gonna be k plus 1 is greater than log base 2 plus k plus 1, right? And then I know this is gonna be greater than or equal to log base 2 of k plus 1 because it was from the question A. We use this inequality, right? And yeah, in this case, we show that for k plus 1, this claim is true. You can write or if true for n equal k, then true for n equal k plus 1 as true for n equal 1. Therefore, true for all n positive integers. Yeah, that's it. Question 9. Consider the homogeneous differential equation dy divided by dx equals x minus y divided by x plus y. where x greater than 0 and y does not equal to -1. It's given that y equals 0 when x equals 2. By using the substitution y equals y times x, show that the solution of the differential equation is x squared minus 2 times x times y minus y squared equals 4. So I will use this substitution, this equation uh, in this differential equation. So I know that y equals y times x, but I need that the derivative of this whole function. Firstly, I will use the derivative of y in terms of x, and since there is here a product, I will use the product rule of differential, derivative. So what's the product rule? I first find the derivative of v in terms of x, then multiply it by x plus the first one times the derivative of the second, which is derivative of x in terms of x is 1. So I will replace dy over dx with this expression. I can write this one plus v equals, I will replace y with v times 6. So this is our equation. Now I will try to solve. And actually you can cancel these x's. It's gonna be 1 minus v divided by 1 plus v. So what is there now? Let's simplify this equation. dv divided by dx times x. Subtract v from both sides. It's gonna be 1 minus v divided by 1 plus v minus v. And you can say that I will continue from here. dv divided by dx times x is gonna be 1 minus v minus v minus v squared, because when you multiply it by this expression, divided by 1 plus v. From here you can say that dv divided by dx times x equals 1 minus 2 times v minus v squared divided by 1 plus v, right? So from here, I will continue and say that let's make a cross product here and replace, change the place of this expression, this fraction to the left side, and it's gonna be dv times 1 plus v divided by 1 minus 2 times v minus v squared equals dx divided by x, right? So we're gonna use now the integral of both sides, and you can see that since there is a derivative of the denominator is at the denominator, so you can use the function ln. Actually, this is ln, and you can write the absolute value of 1 minus 2 times v minus v squared. And when you see that the derivative of this expression, which is minus 2 minus 2 times v, the derivative of this, in this case, we need to divide it by minus 2 to cancel this minus 2 and just remain 1 plus v. At the right side, you can also write this one ln x, because I know that you can also check from the formal booklet all the integral of 1 over x is ln x. By the way, do not forget to see the constant value. So from here you can also multiply it by minus 2 of both sides. You will see that ln in absolute value 1 minus 2 times v minus v squared equals it's gonna be minus 2 times ln x plus, you can say first write minus 2 times c, but it's already gonna be the constant c. You can still replace with this number with c. So what we're gonna do now, and from here you can write, uh, we know that v equals, you can write here v equals y over x. So replace it by y over x. It's gonna be ln 1 minus 2 times y over x minus y squared over x squared. And the attribute of logarithm, you can take this minus 2 to the power of x. It's gonna be ln uh, x to the power of minus 2. And again, is you can also use this constant in the logarithm. This is also the attribute of the logarithm, and you can just write c. Okay, so from here you can also continue to this place. What I have now, ln 1 minus 2 times y over x minus y squared over x squared equals ln x to the power of minus 2 times c, right? Yeah. So I first cancel this absolute value, and since both sides is ln, I will just equal these expressions, and from here you can write 1 minus 2 times y over x minus y squared over x squared equals c times x to the power of minus 2. By the way, we know a point which is 2 and 0 when x equals 2, y equals 0. So I can use this point to find the c. Just replace x by 2 and replace y by with 0. So when you substitute 0 into the y, you will see that here it's gonna be 0, and I know that this x is 2. In this case, that is 1 equals c over 4, and from here you can see that c equals 4. So what we have now, our equation is 1 minus 2 times y over x minus y squared over x squared equals 4 times x to the power of minus 2. And if you multiply it by x squared both sides, you will see that x squared minus 2 times y times x minus y squared equals 4, which is the equation we need to show. Yeah. So we are at the section B now. The question in here has more mark than the section A. Question 10. The function f is defined by f of x equals 5 times x plus 1 times x plus 3, where x is a real number. Write f of x in the form a times x minus h squared plus k. A, h, and k is an integer. I know the function. I will write it here again. 5 times x plus 1 times x plus 3, and it's asked for this form. To do that, I will just multiply these two factors. It's gonna be x squared plus 4 times x plus 3, right? And as you can see in parentheses, especially here, looks like square of x plus 2, because I know that x plus 2 square is x squared plus 4 times x plus 4, right? In this case, you can write in here x plus 2 squared minus 1, because the constant in here is 3. And we done it, but I will simplify again. 5 times x plus 2 square minus 5. Yeah. You can also write, or you don't need to write, what is a, h, and k. Yeah. Question B, sketch the graph of f of x showing the values of any intercepts with the axis and the coordinates of the vertex. We wrote in the function in the form 5 times x plus 2 squared minus 5. So the vertex point is, I know that actually this is the form of the vertex point form. In this case, I know that for the abscissa of vertex point is going to be minus 2, which is h here, and the the y and the y coordinate of the vertex point is going to be the constant, which is minus 5. And if let's check if there is a x-intercept. To do that, I will use the equation and replace y with 0. I know that y is f of x. So it's going to be 5 times x plus 2 square minus 5. From here, you can directly write x plus 2 square is going to be 1. In this case, I know that x plus 2 can be 1, or it can equal be minus 1. In this case, x can be minus 1 and x gonna be minus 3. So these are the x-intercepts. And how about the y-intercept? I will find by replacing x with 0. And let's check what's this. 5 times 4 minus 5 is gonna be 15. So I can graph now the function. Here is the vertex point, minus 5. Yeah, here is vertex point. And the x-intercepts are minus 3 and minus 1. And the y-intercept is gonna be 15. Yeah, we can draw like, mm, yeah, it can be better. So this is f of x. At the question C is asking for this inequality. I know that's f of x, which is 5 times x plus 2 square minus 5, gonna be less or equal to 40. So you can add 5 to the both side. It's gonna be 5 times x plus 2 square less than or equal to 45. And now divided by 5 to both sides, and x plus 2 square is less than or greater to 9. In this case, you can write x plus 2 is less than or equal to 3, or it is greater than or equal to minus 3, right? Yeah. When you subtract 2 from the both side, it's gonna be minus 5 is less than or equal to x, and x is less than or equal to 3. Yeah, we found the solution of this inequality. Sorry, it's gonna be 1, right? Yeah, and the next question, the function g is defined by g of x equals ln x is greater than 0. Write down an expression for f compound function f of g of x. Now, I know that the function f is 5 times x plus 2 square minus 5, and g of x is ln x. And we are looking for the compound function f of g of x. It means you're gonna replace x by ln x in the function f of x. It's gonna be 5 times ln x plus 2 square minus 5, right? Yeah. And at the second question, we're gonna solve the inequality again. We're gonna solve 5 times ln x plus 2 square minus 5 is gonna be less than or equal to 40. So let's do the same things. 5 times ln x plus 2 square is less than or equal to 45. And when you divide it by 5 to the both sides, you will see that ln x plus 2 square is going to be less than or equal to 9. And you can write from here ln x plus 2 is going to be less than or equal to 3, or it will be greater than or equal to minus 3. In this case, you can write ln x is less than or equal to 1 and is greater than or equal to minus 5. But we are looking for the x instead. So I know that uh, we can write minus 5 uh, in terms of ln function and also 1. So what is this? It will be ln e to the power of minus 5 because I know that the base of ln is e. So it will be less than or equal to ln e. In this case, I know I can say that x is less than or equal to e because I'm just now making comparison between inside of the function. So x is greater than or equal to e to the power of minus 5. And the last question is asked for the find the domain of g of f. Uh, we know that g of x is ln x and the function f is 5 times x plus 2 square minus 5. So I'm looking for the compound function which is g of f. In this case, I will just write f of x inside the function g, and it's gonna be ln 5 times x plus 2 square minus 5. So from the attribute of the logarithm, you can say that 5 times x plus 2 square minus 5 is need to be greater than 0. In this case, you will write x plus 2 square is greater than 1 because when you add 5 to the both side and cancel it by 5, it's gonna be 1. From here, you can write x plus 2 is greater than 1 or x plus 2 is less than minus 1 because when you check for the square root of the both side and you will see that the absolute value of x plus 2 is going to be greater than 1. And to solve this inequality, I know this the solution is going to be like this. So x is greater than minus 1 can be, or x can be less than minus 3. We found the domain, or you can just write in the range, which is minus infinity till minus 3, union minus 1, and greater the numbers, the other numbers, minus 1. Question 11. The plane pi1 has equation x plus 2 times y plus z equals 0, and the plane pi2 has equation x minus y minus 2 times z equals 0. The acute angle between the planes pi1 and pi2 is theta. Show that theta is 60 degree. And let's open a new page. And we're gonna write the planes, and the other one is, so I know that the normal of this plane, normal line of this plane is the coefficient of this x, y, and z. So which is, you can say that normal 1, the vector is 1, 2, 1, and normal 2 of the plane 2, the second plane, is gonna be 1, minus 1, and minus 2. Yeah, we are looking for the angle between this actually normals too. So you can just apply the scalar product formula. You can check from the formula booklet. It's gonna be 1 to 1 times 1 minus 1 times minus 2. The second vector will be the magnitude of n1 times the magnitude of n2 times cosine theta. So the scalar product of this is gonna be 1 minus 2 equals square root of 1 plus 2 square plus 1 square, which is the square of these numbers, times square root of 1 plus minus 1 square plus minus 2 square. So this is minus 2 equals, yeah, minus 3 equals square root of 6 times again 6 it is, you can say that cosine theta equals minus 3 over 6, which is minus 1 over 2. And you can just say that theta can be 120 degree, but we are looking for the acute angle, but the acute theta gonna be 180 minus 120, which is 60 degree. Yeah. And the second question, a third plane pi 3 is perpendicular to both the other planes. The unique point of intersection of all three planes is the point, as you can see, find the Cartesian equation of pi 3. So if there is a third plane and this is perpendicular to both other planes, it means the normals of these planes, which is pi 1 and pi 2, and if you find the vectoral product of this two normal line, you will find actually the third plane normal line. So how we're gonna find the vectorial product? This one, and I will take it here to use. Yeah. So what you're gonna write? Uh, yeah, as you can see, these are V1, V2, V3, and these are W1, W2, and W3. Yeah. So V2 times W3, 2 times minus 2 minus V3, 1 times W2 is going to be minus 1. At the second row, V3, 1 times W1, 1 minus V1, 1 times W3. And the last row, V1, 1, W3, I mean W2, minus 1, and minus V2, 2 times W1 is 1. Let's calculate. Here is going to be minus 4 plus 1 is going to be minus 3. In here, you will see that 1 plus 2, 3. In here, again, minus 3. So this is the normal vector of the third plane. In this case, you can write the plane in the form of minus 3 times 6 plus 3 times y minus 3 times z equals, let's say, d. To find the constant, you can use the point which is given in here, r, 5 minus 5, 5. 5 minus 5, 5. It's going to be minus 15, minus 15, minus 15. And then you can see that minus 45. So we found the constant d. You can write the equation of this plane like this, and when you divide it by minus 3, you will see that x minus y plus z is gonna be 15. And the next question, each of the planes pi 1 and pi 2 contains a mirror. A ray of light is directed towards the mirror in pi 1. The ray of light forms an angle of 45 with pi 1 and meets it at the point P. The ray of light is then reflected towards the mirror in pi 2 and meets pi 2 at the point Q. The points P and Q are contained in pi 3. It's given that pi r is 5 centimeter, and as you see in the following diagram, the question is, using an appropriate compound angle identity, show that sine 75 equals this. Yeah, so you can check the compound angle formula of sinus, and you can write sine 75 like 30 degree plus 45, because I know that the output of this function when it is 30 and 45. And the formula is sine 30 times cosine 45 plus sine 45 times cosine 30. So what is sine 30? It is 1 over 2, and cosine 45 is square root of 2 over 2 plus square root of 2 over 2 times cosine 30 is square root of 3 over 2. is gonna be square root of 6 plus square root of 2 over 4. We found it. And ask for find QR, giving your answer in the form like this. So what is QR? Here we're gonna find this length, and we know that this angle is 75. And what else we know? Yeah, that's enough actually, right? So we can use the sine theorem. What is this? The length of opposite this angle, I mean the length of this line, which is at the opposite of the 75, you will write 5 over sine 75 equals the length of the line opposite of 45, which is QR over sine 45. Yeah, I will use like this. Yeah, so let's apply these numbers. 5 over sine 75, we found it at the previous question. It's gonna be this number equals QR over square root of 2 over 2. So QR, the length of QR gonna be 5 times 4 times 2 divided by square root of 2 times square root of 6 plus square root of 2, right? Yeah. No. 2 is gonna be here, square root of is gonna be here. And then we will cancel 2 first. 10 times square root of 2 divided by, just make a common factor, square root of 2. And in parentheses, you can write square root of 3 plus 1. And we're gonna write, yeah. So the conjugate of this irrational number is gonna be square root of 3 minus 1. And when we multiply the up and down, we will see that 10 times square root of 3 minus 1 divided by 3 minus 1, so which is 5 times this number, and P is 5, Q is 3. Yeah, the last question at the paper 1, time zone 1. Consider the family of functions fn ox equals cosine to the power of nx, where x is a real number and n is a natural number. By writing cosine to the power of n as cosine to the power of n minus 1 times cosine x, show that this integral. And we're gonna replace this by cosine to the power of n minus 1 x times cosine x. So what we're gonna do in here, we do usually integral by parts. For example, you would say that cosine to the power of n minus 1 x gonna be u, and cosine x dx equals dv. So finding the derivative of the both sides the first equation, it will be n minus 1 times cosine to the power of n minus 2 times minus sine x, which is derivative of cosine, dx equals du, and I'm looking for the integral of this both parts to find v. So the integral of cosine is gonna be sine x equals v. In this case, you will write u times v, which is cosine to the power of n minus 1 x times sine x minus v times du, and it is sine x times this one, right? So let's simplify this again. You can take this n minus 1 and the negative sign out of the integral, and you can write plus n minus 1 times integral. It's gonna be sine square times cosine to the power of n minus 2x dx. So instead of sine square, you can write minus or 1 minus cosine square. If you write like that, you will see that is cosine to the power of n minus 2x minus, let's say, another integer. You can also write first inside cosine to the power of nx, right? So let's check what we should show. Yeah, the first part is here, I think, and the second part is gonna be this, and then this one. Actually, we found it. Yeah, it's the same times sine x minus n minus 1 times an integral cosine to the power of nx dx plus n minus 1 times an integral cosine to the power of n minus 2x dx, right? Yeah. Hints show that the other integral and at the question B. Yeah. By the way, you are not allowed to write in this page. I mean, like you need to open it another page, but I will write in here. So how are we gonna do now at the second question B? And we know that integral of cosine n to the power of n x dx equals so yeah, from the previous question, we found it like, let's write it again. Cosine to the power of n minus 1 x times sine x. And I will write and multiply it into the parentheses, this one, minus n times cosine to the power of nx dx, and plus cosine to the power of n x, right? Or yeah, plus n minus 1, the same integral. So when you first cancel these integrals because they are the same and add to the both sides this expression, you will see that n times integral cosine to the power of nx dx equals at the right hand side. And then you can say when you divide it by n to the all of the sides, you will see that cosine to the power of nx dx equals cosine to the power of n minus 1 x times sine x divided by n plus n minus 1 divided by n cosine to the power of n minus 2 x dx. So yeah, we found that this means that integral fn equals 1 over n times this expression plus n minus 1 over n in integral f n minus 2. Yeah. Or actually fnx. At the question C, hints find an expression for to the power of 4, this cosine to the power of 4. So you can write 1 over 4 times from the previous solution cosine to the power of 3x times sine x plus 3 over 4, which is cosine square. And from here you can write 1 over 4 and the same expression in here. So you can also apply the formula which we found in the previous one. We will just replace n by 2. I will write 1 over 2 times cosine x times sine x plus it's gonna be 1 over 2 again, and integral of, it looks like cosine to the power of 0, and you can say that from here, let's simplify, it's gonna be 3 over 8 cosine x times sine x plus, so it's gonna be, and plus 3 over 8 times x, because I know that the integral of 1 is x. And do not forget the constant c. At the question D, it is asked for the region. There is a region R is rotated by 2 times pi, and this is the graph of cosine square x, and we're gonna find the volume of the solid in here. So I will apply again integral formula here to find the volume, and I know that the limits in this integral is minus pi over 2 and pi over 2, and to find the volume we are just multiplying by pi the square of the function, which is, the function is cosine square, and I will take the square of this again. So we'll find this integral, which is cosine to the power of 4x. We already found this at the previous question and here, so you can just write this expression in here. The integral of this function is gonna be 1 over 4 times same. You don't need to write the constant in here in this integral because we are already gonna apply the limits of this integral. So the limits is pi over 2 and minus pi over 2. So when you replace pi over 2 with x, if there is cosine, it's gonna be 0. In here, 0, because I know that cosine pi over 2 is 0, times 3 times, 3 over 8 times pi over 2, minus, now I'm replacing minus pi over 2 with x. So again, it's gonna be 0 when you substitute minus pi over 2 in cosine function. So again, 0 plus 0, but now minus 3 over 8 times pi over 2. So it's gonna be pi times 3 times pi. Did I write? Yeah. Over 16 plus 3 times pi over 16, which is gonna be pi times 3 times pi over, let's say, 8, right? Yeah. This is the answer of the question, or you can just write 3 over 8 times pi square. At the question E, find the Maclaurin series of f and x up to the term in x square. I will write here the answer of this question. We found f and x, right? What is this? It was cosine to the power of nx. So what is Maclaurin series? There's also formal and formal booklets in here. You can check it. And this is, you just need first derivative, which is n times cosine the power of n minus 1 x times minus sine x, which is derivative of cosine. And from here you can write minus n times sine x times cosine to the power of n minus 1x. At the second derivative, we will write, let's say, the product rule, minus n, in parentheses you can write the derivative of the first sine x, which is cosine x, times cosine to the power of n minus 1x, plus sine x times the derivative of the second expression here. You can write n minus 1 times cosine to the power of n minus 2x times minus sine x. You can simplify it, but you don't need to simplify it because we are already gonna substitute 0 in this function, because in formula we will find this f0 plus the derivative of x, f of x, at the point 0, plus the derivative, there is also x here, divided by 1 factorial, plus the derivative, the second derivative of the function at the point 0 times x squared divided by 2 factorial. So what is f0, f0 or fn 0? Here is n. It is to the power of 0, and I know this is 1. And again, and at the first derivative, the point 0, you will check this expression, and it's gonna be 0 because of this n. Or no, we are applying 0 into the x, so it's gonna be minus n, but because of sine, it's gonna be 0, yeah. So we found also the first derivative at the point, and you can also find the when you apply or substitute 0 with this, it's gonna be here 1, and here gonna be 0, right? Yeah, here gonna be 0. In this case, we can write now the solution. It will be 1 plus 0 minus n times x squared over 2. Yeah. And I will take this one to find the last question. The last question is asking for when our limit x approach to 0. So to find this, you can also use the Maclaurin series of function f and x. We found it here. 1 minus this one. Minus 1 divided by x squared, and the limit x approach to 0. It is, you can cancel 1. And also we're gonna cancel x squared, and it's gonna be just minus n over 2, right? We finished HL Mathematics Paper 1 questions from May this year, and this was the time zone 1, and I will also share the other time zones, which is time zone 2 and time zone 3. I hope it's gonna be helpful for you, and see you at the next solutions video, which is gonna be HL Paper 1 time zone 2 from the same exam, which is in May. Bye bye.